Welcome to 6.4 complex fractions. We're going to be simplifying complex fractions, and we're going to use rules of dividing rational expressions to help us do that. We're also going to be simplifying complex fractions that have a sum or a difference in the numerator and or denominator. So to start off, what is a complex fraction? Well, a complex fraction is a fraction that has a fraction in its numerator or denominator, and sometimes both. So it's basically a fraction within a fraction. And I give you an example down here. This is the main fraction line. So your numerator, it contains a fraction, x plus 2 over 3. And your denominator also contains a fraction, x minus 2 over x. So these are problems that involve the division of two rational expressions. Remember, a rational expression is just a fraction. So two fractions is a complex fraction. Well, how do we simplify this? Well, remember that division is the same as multiplying by the reciprocal. So I can rewrite this as 5 over 14 times, so instead of division it becomes times, and we're going to flip our second fraction. The one in the denominator gets flipped. The one in the numerator stays the same. So instead of 25 over 8, now it's 8 over 25. And I simplify, so 8 times 5. Remember, we multiply fractions straight across, tops times tops, bottoms times bottoms. And 14 times 25 is 350. However, this isn't simplified. I can divide both of these by 10. And when I do that, I get 4 over 35. This is a simplified fraction. Okay, another two examples. Let me change my pen here. Same thing. We have division, so we're going to multiply and flip. You may have heard this as keep, change, flip. So I'm keeping my numerator, 4y cubed over 5x quantity squared. And I'm going to be multiplying this by 10x cubed over 2y quantity squared. Multiply straight across. 10 times 4, those are just numbers that I can multiply. I have a y cubed times an x cubed. I can't combine those anymore. They don't have the same base. So it's a y cubed times an x cubed. In my denominator, make sure I understand what this means. So 5x is in the parentheses. That means the 5 is being squared and the x is being squared. So if I were to simplify this, it'd be 25x squared times, and then same thing over here, distribute that 2 to the 2 and the y. So we're squaring the 2 and we're squaring the y. Simplify it a little more. 25 times 4 would give me 100. And remember, I can't multiply an x squared with a y squared. Now I'm going to see if there's anything that cancels. And the first thing that I want to look at is my number, 40 over 100. So some of you keep asking me questions about this. How do I simplify it? Well, you want to either type in your calculator 40 divided by 100, and there should be a little button on there that says F and then arrow D and then like an arrow the other direction. So what that means is fraction to decimal and decimal to fraction. So when you type in the 40 divided by 100, it gives you a decimal, and then you'd hit second and then this FD button and then change it back to a simplified fraction. The other thing that you can do is both of these again they're divisible by a little bit more than 10. Actually, this would simplify to 2/5, so they're both divisible by 20. And also you want to note that I have x's and y's that will cancel. So I have 2 in the bottom and 3 in the top. So that The 2 in the bottom will cancel, and then I'd be left with 1 in the top. Same thing with my x's. So the simplified form of this would be 2 over 5, and xy is in the numerator. There's no xy in the denominator. Down below, same thing. I want to write this as a keep, change, flip. So I have x plus 1 over x plus 2 times x plus 5 over x plus 1. And when I multiply, I want to see if anything cancels. So it's all of x plus 1 times all of x plus 5. And x plus 2 quantity times x plus 1. So notice that my x plus 1's cancel, and I'm just left with x plus 5 over x plus 2. In these problems, we're not going to worry about the domain. Obviously, there would be domains here, restricted domains like where x can't equal 2. It gets a little bit tricky in these complex fractions because we can't have any denominator be 0 throughout the entire problem. So there's a denominator here and denominator here, and then we have new denominators here, and then more denominators over here. It gets a little bit messy. So I'm not going to be concerned about the restricted domain, and I don't believe WebAssign asks for it either. Continuing on with problems 4 and 5. One thing that I want to note here is that it may not look like there's a fraction in the denominator, but there is. This is 2x plus 6 over 1. So let's keep our numerator the same, x squared plus 4x plus 3 and x minus 2. Then we're going to change division to multiplication and flip our fraction. So we get 1 over 2x plus 6. Now remember when we were multiplying in the previous section, let's, instead of multiplying straight across, let's factor. So x squared plus 4x plus 3 can factor into x plus 3 and x plus 1. And then times 1, I don't really need to write. Anything times 1 is itself. Down below, I can't factor the x minus 2, but I can factor over here. I'm going to pull out a 2, and I'd be left with x plus 3. Now that I've multiplied and factored, let's see what cancels. I have an x plus 3 quantity, but it looks like that's all that is going to cancel. So in my numerator, I have x plus 1. Denominator, I have x minus 2 times 2, and I'm just going to write the 2 out in front for proper notation. And that's as far as I can go. Down below looks a little bit crazy, but it's okay because we're really good at factoring now. So to save on space, I'm going to factor as I keep, change, flip. So if I'm factoring my numerator, I would write this as x plus 2 and x plus 3. Okay, that's the numerator of my top numerator. I know it's the numerator of the numerator. So x plus 2 and x plus 3. And then down here, to me, the thing that sticks out is I notice that my a is a perfect square number, right? 4 is 2 squared. And my c is a perfect square number. 25 is 5 squared. So this is actually a perfect square trinomial. And I don't know if you remember, hopefully you do, but in chapter 5, a perfect square trinomial, we wrote as one set of parentheses, quantity squared. In the first space is the first thing being squared. So 2x would give us 4x squared. And the last position is the last thing being squared. So that would be the number 5. 5 squared would give us 25. And then how did we determine what sign went here? Is it a plus or a minus? Well, the minus, or the very first sign is minus, so a minus sign would go there. Okay, that's the numerator factored. Now we're going to keep, change, flip. So we're changing division to multiplication and flipping our denominator. Well, while I'm flipping, I'm going to factor it. So keep in mind, my numerator is going to come from this 4x squared minus 25 because I'm flipping it upside down. So this is the difference of two squares. So difference of two squares gets two sets of parentheses. One's plus and one's minus. Now the very first item in the parenthesis is the first thing being squared. So it would be 2x. And the last item would be the second thing being squared. So a 5. Okay, now for the denominator. So it's coming from the x squared minus 5x minus 24. That trinomial can be factored into two binomials. So x minus 8 and x plus 3. Those two numbers multiply to negative 24 and add up to negative 5. Now I'm ready to multiply and cancel. So right off the bat, I notice I'll have an x plus 3 in the top and an x plus 3 in the bottom. And this squared means that I have an 2x minus 5 twice over here. So I have a 2x minus 5 in the top. I'm going to cancel it out with just one of these. Notice that I cannot cancel it with a 2x plus 5. Those are different. So after I've canceled out everything, my remaining answer is x plus 2 times 2x plus 5 over 2x minus 5 times x minus 8. Now, complex fractions with sums or differences. So this is kind of combining adding and subtracting rational expressions with multiplying rational expressions. So we want to make sure anytime we're adding rational expressions that it has a common denominator. Okay, so put that in your notes, star at something, need common denominator. Looking at our numerator, it looks like we do have a common denominator there. We're adding these two fractions. That's fine because they both have a 3 in their denominator. But look at your denominator here. I have 1 over 1 and I have 2 over x. So this needs a common denominator. Well, what's common between 1 and x? Well, that's x. We need the LCM. So what I need to do is fix my denominator. And I'm maybe going to do it off to the side out of the way here. So I want to multiply or get a common denominator of x. 2 over x already has it. So what should I multiply by over here? Well, it's lacking an x. So if I multiply the bottom by x, then I need to multiply the top by x. So x over x plus 2 over x stands for my denominator. Pretty soon you'll get good at this and you won't have to do this work off to the side. You could do it intermixed with your work to solve the problem. But for now, I'm showing you it off to the side so that you can see where my numbers are coming from. All right, so I rewrote the denominator. So now the problem looks like this. X over 3 plus 2 over 3 divided by x over x minus 2 over x. So I'm ready now to simplify my numerator and denominator by adding and subtracting. So in the top, remember we don't add denominators, we add numerators. So we have x plus 2 over 3. And in the bottom I have x minus 2 over x. Okay, so I've simplified my numerator and denominator. Now I'm ready to keep, change, flip. So we're keeping the first fraction, changing division to multiplication, and flipping our denominator upside down. Simplify this. So I have x plus 2 times x over 3 times x minus 2. There's nothing here that's going to cancel, so this is my simplified form. Remember, when you are finding common denominators, that you have to change the numerator. Okay, we can't just write this as 1 over x. That's incorrect. So if we're changing the denominator of 1 to x, then we have to change the numerator as well with multiplication. Okay, back to the bottom. I need to rewrite this. So look at my numerator. I can't add a 3 plus 9 over x minus 3 until I have a common denominator. And same thing down here. I can't add a 4 with 12 over x minus 3. These have denominators of 1. Okay, so I can't add. They don't have common denominator. So how do I do that? So let's just work with the numerator. 3 over 1 plus 9 over x minus 3. What would be the LCM between these two fractions? Well, that would be x minus 3. So I need to get this denominator to look like x minus 3, which means I need to multiply it by x minus 3. And if I'm multiplying the denominator, I have to multiply the numerator. And my new fraction for the numerator would be 3 times x minus 3 over x minus 3 plus 9 over x minus 3. Okay, so my first fraction is the only thing that changed. So this 3 here, I rewrote it. Let's do the bottom. Let's change the number 4. So I have 4 over 1 plus 12 over x minus 3. And my common denominator here would be x minus 3. And obviously the second fraction has an x minus 3, so I don't need to change it, but I do need to change my 4. I need to multiply by x minus 3 in the top and in the bottom. That would make my new numerator 4 times x minus 3. Now that I've rewrote it with common denominators, I'm ready to start solving. So let me clean this up here. So we made 3 times x minus 3 over x minus 3, 9 over x minus 3, divided by 4x minus 3, x minus 3. Okay, I've rewrote both my fractions with the common denominator. Now I'm ready to add them. So remember, we don't add denominators, but we do add numerators. So in my numerator, I have 3x minus 3 plus 9. My denominator, I have 4x minus 3 plus 12. I still haven't keep, change, flip yet, so I need to do that now. All I've done was find a common denominator and add my fractions. So let's keep the numerator. Change division to multiplication and flip my denominator. Now I want to caution you on the simplification part. Because I see a lot of mistakes coming from students wanting to cancel when it's not possible to cancel. So let's talk about this. look at your very first numerator. There are two terms here. Okay, and if you want to imagine a parentheses around them, you can. The reason I say there are two terms is because terms are separated by addition signs. One whole term is when you have everything being multiplied. So this is a term because I have two things being multiplied. I have a 3 and I have this x minus 3. This is one quantity. It's in parentheses. This is one term. My other term is 9. These two terms are separated by this addition sign. I have the same thing going on down here. 4 times x minus 3 is one term and 12 is another term. So how does that change my simplification? Well, think about it this way. You have two terms here that you can factor something out of. What is in 3 times x minus 3 that's also in 9? Well, that would be a 3. If you factored out a 3 from each of these, you'd be left with x minus 3 plus a 3. Okay, we're pulling out a 3. He's no longer there, and he changes to a 3. So we have x minus 3 plus 3. That's how I got that. Now, we're multiplying it times, all of it, times the x minus 3 over here in my other numerator. Okay, so everything in my numerator now is being multiplied. 3 times this big old set of parentheses times this set of parentheses. Okay, so I have all one term up here. In the bottom, I'm going to do the same thing. I can't factor the x minus 3 anymore. But what I can do is factor this because this is two terms, remember? So I'm going to pull out what they have in common. I'm going to take out a 4 from both, the 4, x minus 3, and the 12. When I factor out a 4, I'm left with just the x minus 3 in parentheses. And I take out a 4, I'm left with a 3. It's kind of like division. Okay, now my denominator is all being multiplied. Okay, parentheses mean multiplication. So let's look at what we have in common now. What can we cancel? Well, obviously the x minus 3's cancel. But look at this big set of parentheses. I have an x minus 3 plus 3 in the top and an x minus 3 plus 3 in the bottom. Those are one term that is being canceled. It's one term because it's in a set of parentheses. It's an entire quantity. Now what remains is your 3 in the numerator and your 4 in the denominator. So this entire problem simplifies to 3/4. Kind of amazing. After all that algebra, we get one number. Folks, please ask questions at this time if you have them. Simplifying complex fractions again. So this is problem number 3. We have this one and one more. I'm going to do the same thing. Remember, if you see a sum between two fractions, so I have fraction 1 plus fraction 2, I need a common denominator. So remember, what's the LCM between x plus 2 and x? Well, I have to have one of each, and I have to have the highest degree. So my LCM here is x times x plus 2. I don't have to worry about my numerator. I'm not adding it with any other fraction. So my numerator is staying the same. 2 over x plus 2. Now I need to worry about rewriting my denominator with common factor. So 3 over x plus 2 and 2 over x. I need these guys to look like they have denominators of x times x plus 2. So what is lacking in my first fraction? Well, it has an x plus 2, so it looks like I need to multiply it by x. When I do that, my numerator now becomes 3x. Second fraction is lacking in x plus 2. So this is going to become 2 times x plus 2. Okay, now I have my fractions. I can combine them. I'm just going to add them here so that I can put them up in my original problem. When I add these, remember my denominator stays the same. And I have 3x plus, and I'm actually going to distribute my 2. So I have 2x plus 2. It looks like I have some items that I can combine. So the 3x and the 2x would make it 5x plus 2 over x times x plus 2. Remember this, what I just did was adding my denominators. Okay, so I haven't keep change flip yet. I just simplified my denominator by adding the two fractions. So I have 5x plus 2 over x times x plus 2. Now I'm ready to keep change flip. So I'm going to keep numerator, change division to multiplication, and flip this. And I'm ready to cancel. So I have 2 times x plus 2, x plus 2 times 5x plus 2. What's in the top and in the bottom? Well, the x plus 2's. Tell me, why can I not simplify or cross out the x's here? It's because this is one whole quantity, okay? So it's not possible to cancel out my x's because my denominator isn't being multiplied by anything, right? There's a plus sign separating the 5x and the 2. Okay, so if there was in the numerator a 5x plus 2, I could cancel them out because this 5x plus 2 is one quantity in itself, separated into two terms. Okay, I cannot cancel the x's. The only time that you can cancel is when everything is being multiplied. Okay, and I don't have that in the denominator, so I cannot cancel, and this is as far as I can go. Last problem, simplifying complex fractions. So notice here that I have an x to the negative 2, and down here I have an x to the negative 1. So we first want to rewrite this with positive exponents. Okay, so maybe leave yourself a note. Rewrite with positive exponents. Well, how am I going to do that? Well, I need to use my chapter 5 skills. So see, it's important that we master those at least 75% or better. So my numerator is 5 plus something. So if I'm changing a negative exponent, I want to make it positive, I have to take it to the denominator. So x is being raised to the negative 2. That means x goes to the denominator and the exponent changes to positive. Well, if there's nothing with it, there gets to be a 1 in the numerator. So that's the numerator. And denominator, I want to write with positive exponents. So here I have 8x to the negative 1. What is the negative 1 actually on? Well, it's only on the x, so I bring the x down, and the 8 is still up here. He doesn't get to go in the denominator because this x minus 1 only applies to the x. If the problems were like this, the negative 1 applies to everything. So you would bring the entire 8x down with a 1 in the numerator. But it's not. The negative 1 is only on the x, so only the x gets to go to the denominator. And then we have plus x. Okay, so I rewrote it with positive exponents. Now I want to simplify by adding my numerator and adding my denominator. Well, remember, we can't add fractions unless they have a common denominator. So let's go ahead and work that down here. I have 5 plus 1 over x squared. Common denominator would be x squared. Remember, 5 as a fraction is 5 over 1. So how do I rewrite these with x squared in the denominator? Well, 1 over x squared already has it, so I don't need to change it, but I do need to rewrite 5 over 1. I'm going to need to multiply the 1 by x squared, so that means I need to multiply the 5 times x squared. 5 times x squared would be 5x squared. This is my numerator. Denominator, 8 over x plus x. Remember, that's x over 1. So a common denominator here would be x. And it looks like 8 over x already has a denominator of x. I don't need to change it. But what I do need to change is this denominator. 1 times x would give me x. So I need to multiply x times x, which would be x squared. This is my new denominator. So back up to the original problem. Actually, let's simplify these. So let's add. That way we don't have to do it in purple. So when I add, I get 5x squared plus 1 over x squared. That's my numerator. Down here, I have 8 plus x squared over x. That's my denominator. Now remember, all we did was just add these two fractions in the top and in the bottom. Now I'm ready to keep change flip. Keep the numerator, change multiplication to division, and flip the denominator. Remember, when we multiply fractions, we want to look for things that factor. So I don't see anything here. I don't see difference of two squares. I don't see perfect square trinomial or any other trinomials. Nothing can be pulled out of this. Nothing can be pulled out of this. So I just have the x times 5x squared plus 1. And in the bottom, an x squared times 8 plus x squared. Oh, I noticed that my numerator is two things being multiplied. Okay, so the x is being multiplied by this entire parentheses, and same thing down here. So this is an instance where I can cancel. Everything's being multiplied. Ugh, I keep doing that. So what cancels? Well, the 5x squared plus 1 doesn't match with anything in the bottom, and same with the 8 plus x squared. But I do notice that I have an x here, and I have an x times an x. I can cancel out 1. So my numerator, all that's left is the 5x squared plus 1. In the denominator, I have an x times an 8 plus x squared. And that concludes our notes for 6.4. If you have any questions, please don't hesitate to ask. If you want to see me work another problem, please ask. There are practice problems in your book that you can look at. Don't think that this video notes is the end of our learning. Okay, keep continuing to practice and try these. If remember you want to pause the video, try to work it out, do that. But if you need help, just please, please, please let me know.